Here's another one that's going to require multiple derivative rules. So let's take a look at it. We want to differentiate this function g of t, which is t minus 2 over 2t plus 1 all raised to the power 9. And so we want to think about what is the main operation here? What do we have to kind of differentiate through first? And if we're looking at this, it's actually a composition. The main operation here is a composition. It's a composition of two functions. So our outer function, that's this power function. We have this whole thing raised to the power 9. So our outer function is that raised to the power 9 function. And then our inner function is what's inside the parentheses. So our inner function here is that t minus 2 over 2t plus 1. All right, so we've identified that we have this composition. We've identified our outer and our inner function. Whenever we have a composition, that means we need to use the chain rule. So let's do it. Let's use our chain rule. And we're going to start by just kind of breaking through that outer function. We're going to calculate g prime of t. So we start with our chain rule. And we're going to differentiate that outer function. So bring down the 9. Keep what's inside the parentheses exactly the same. And then subtract 1 from the exponent. So that's the derivative of our outer function. Bring down the 9. Keep what you have the same. And then subtract 1 from the exponent. And then we take our inner function, t minus 2 over 2t plus 1, and we multiply by its derivative. So that's chain rule. It's chain rule that we've done there. And what chain rule is really allowing us to do is we're kind of breaking through. We're differentiating our way through that outer function. So we've differentiated the power function part, and now we have to calculate the derivative of the inner function part. And if we're looking at this, it's not a basic function that we can differentiate. It's a fraction. So that might be the first thing we notice. This thing is a fraction here. And we notice some variable terms on both the top and the bottom. So whenever we have a fraction with variables on both the top and the bottom, a lot of the time we want to use quotient rule. And that's what we're going to use here. We're going to use some quotient rule on this to differentiate this fraction. All right. So let's see how that's going to look. So this first part, we're done with that. So we still write it down, but we're done with that. No more differentiating in here. Now we want to differentiate with the quotient rule. So the way we can implement our quotient rule is to write down our fraction, write it as a product. So top times the bottom. And then just 2 copies of that. In the first copy, we apply the derivative to the first part. In the second copy, we apply the derivative to the second part. And then we subtract, put subtraction there in the middle. So it kind of starts off like the product rule, but then we put a minus sign there in the middle. And then we take our original denominator, which was 2t plus 1, and we square it. So we have 2t plus 1 squared now in our fraction. All right, so what we've seen here, this is our quotient rule. The chain rule kind of broke through the outer function, and the quotient rule now kind of differentiate our way through that division. We still have some more derivatives to go, but now each step of the way they're getting easier and easier. So we're kind of working our way through this. And so we have this t minus 2 which needs to be differentiated, and that's just a polynomial. We can do it. And then we also have this 2t plus 1 which needs to be differentiated, but again, that's just a polynomial. We can do that easily. So we just keep going until we get to a point where it's just some basic derivatives that we can just do. So this derivative of t minus 2 is just 1. And then the derivative of 2t plus 1 is 2. And that's good. We can stop there. We're just finding the derivative. If we wanted to, though, we could. There is some simplifying we could do here. So, we don't normally write multiplication by 1. We could actually multiply this 2 through and then do the subtraction. And I think this does simplify down a little bit. So you might try that for yourself. But if just getting the derivative, we could stop here. And that's fine. All right. We're going to look at one more example next of just kind of going through these problems in kind of a sequential order of applying different derivative rules. So first here, we had to use chain rule to kind of break our way through that outer function. Then once we got through the outer function, we had to differentiate a fraction. So the way we did that was with quotient rule. And then once we applied quotient rule, the pieces that were left to differentiate, we could just do. All right.